I appreciate you rolling with the technical punches. It's always fun doing presentations during a time of COVID, and I can actually say it's very different. Like, I know we have maybe 50 something people um, on the screen. Actually, 64 people here at the moment, but the energy always feels a little bit different virtually. So I really appreciate everybody's time and attention. Thanks again, Tim, by the way, and Brian for the great introduction. I'm really excited to talk to you about cookieless attribution. So let's try this again. There we go. So, hey, I'm Dr. Joe Sutherland. I'm the head of data science and search discovery. I work with Tim and actually several other people on this call, either in the past or currently, and I appreciate working with every single one of you. I'll also do a little shout out to the Ohio folks. I'm sure it's pretty cold right now. And I'll in particular do a shout out to Pawan, for whom I'm sure it is even colder. So I really hope everybody's staying warm out there and hope that this talk will maybe keep you a little bit warmer. All right, so who knows who this guy is? Anybody familiar? We got one, I see one hand. I also can't really see hands because I got like 5 faces in front of me, kind of on this side video camera thing. So, I'm just going to assume people putting their hands up. If you have any idea who this is, come off mute. Feel free to just, shout his name out. I can't see who you are.
John Wanamaker.
John Wanamaker. John Wanamaker. And if you put it in the chat, thank you as well.
Other interesting fact about him, he invented the price tag.
I mean, that's a fascinating fact. Like, who can claim credit for something so revolutionary? John Wanamaker was quite a force in marketing. He was the inventor of the department store, was kind of his major contribution, and among other things, invented the price tag, and even invented, at least I hear, the money back guarantee. So very, very influential guy, very, very sort of like one of these geniuses of marketing. But something that he's, was oft quoted in saying was that half of the money I spend, I being John, on advertising is wasted. So he knew that half his money was being wasted. The trouble was, of course, that he didn't know which half it was. And this is a problem that most marketers deal with. Marketers want to know if they're putting their money in the right places. Now, fast forward maybe 100 and something years, and now we're in the digital age. And one of the tools in the digital age that we use to figure out where where we're getting the most bang for our buck is multi-touch attribution. And multi-touch attribution, or MTA, as I'll abbreviate it, is the attempt to accurately assign value to each channel or tactic that customers may encounter during their paths to purchase. And so it's trying to give us an idea of when customers interact with certain parts of our brand or certain experiences that we put out there through any number of marketing or media channels, how do we understand which one of those things was most likely to have led to their purchase or other, any type of conversion, some sort of interaction that's desirable with our brand. Now, there are 4, fundamentally different ways of approaching multi-touch attribution. A lot of us have heard of these, heuristic modeling and algorithmic modeling in particular, I think are things that have been around for a while. We're not going to discuss traditional MTA, and I'm going to assume that you're likely familiar with that. I'm also happy to come back to it. Maybe we can have a dialogue later if you're kind of being left behind, but that's something that we're not going to discuss necessarily during this talk. At a high level, just to kind of summarize it in a sentence, it's an attempt to track user level data across various touch points and then follow them through to conversion so that you can build some sort of model to understand which part of your marketing strategy was most influential on that person's choice to convert or make a purchase. Now, increasingly, these traditional MTA methodologies are becoming less viable. And of course, there's trade-offs between the different approaches, as we'll talk about in just a second. But traditional MTA is becoming a less viable option. One of the reasons is that it requires connecting user-level data across all those individual touch points, which, as we discussed earlier, is actually a very relevant part of business for some of our sponsors. In particular, for example, online and offline unification across devices or users. It's always been hard to do, requires a huge data lift, and is increasingly difficult, especially as we get into privacy, sort of the new regime of privacy, which has been all that we've talked about in this last year. And so, I'm going to talk today to you about sort of these next generation approaches, right, which are media mix modeling, which again, a lot of you might be familiar with, and controlled experimentation, which is really what we're here to talk about, the RCT, the randomized controlled trial. And so these two approaches are somewhat complementary. In a media mix model, you take historically observed data on how much you spent, you slice and dice it by channel, by time slice, by geo. And then on the other, the other side of the equation is the results that you saw. So, the number of purchases that came through, the amount that was purchased, kind of in an overall revenue perspective, or maybe the number of downloads that you were interested in from a conversions perspective. And the result of a media mix model is an estimation of the impact of each channel in a multivariate sense, or potentially even including interactions across the different channels on the ultimate outcome of interest, which might be, for example, your bottom line revenue or your downloads. Now, one of the major limitations of media mix model approaches, although they are very useful, is that the quality and accuracy of the results are, number one, highly dependent on the granularity of the data. So your ability to actually slice and dice the data by the channels that you have, or the time period that you have, or the geo that you have, which is very, very difficult, especially when all you see is people coming through a funnel and you don't know where they came from. It's highly dependent on variability in the data, right? And so when you look at a channel that, for example, is always sending in maybe one or two people a day, that may not seem like a lot, but if you have other channels that are only sending in one a day, there's not going to be enough variability for you to actually understand what the media mix overall should look like to be optimized. And finally, and we'll get to this in just a second, but you cannot get an approximation of causality in media mix modeling. You cannot get an approximation of causality. And causal inference is very, very important because it helps you understand what A, what you did, what A led to the actual impact that you care about, the B. A good example of this would be if you run a media mix model where, maybe in the past you saw like a paid search investment, increase, and you also saw your traffic on your website decrease, for example. The media mix model is going to tell you that there's a negative relationship between your spend on paid search and the amount of traffic that you get through on your website, which doesn't really make a lot of sense, right? And the implication of that is, well, because of that negative result, you should probably spend less on paid search, right? It doesn't take into account the causality that may have led to you observing those data, right? And I can actually offer you a real world sort of example, which is in the case where we observed that, for a client analysis where we observed that negative relationship. In reality, what was happening was the paid search spend was increasing in response to decreasing visits at the website. So you kind of get this problem where you're not sure if the chicken caused the egg or the egg caused the chicken. And that can be very, very problematic, especially when you're trying to determine where to spend your very scarce marketing dollars. With controlled experimentation, you introduce a design-based variability. We call it an instrument in spend across your channels, across the different marketing tactics that you use, at different points in time or in different geographical areas. And you link that sort of synthetic variability back to the observed results and outcomes that you actually care about. And because you've put a design out there in a way that is entirely uncorrelated with anything else that the world can throw at you, you end up with the ability to make causal inferences about the impacts of those channels and tactics. there's other benefits that we're about to talk about, which is kind of how we get to the cookieless world, but that at a high level is what we're trying to do with controlled experimentation. Now, more formally defined, a randomized controlled trial, and I'm going to read the text on this slide, so I apologize. I hate when I do that, but it's important enough to kind of get it ingrained in your memory. A randomized controlled trial is a type of scientific experiment that aims to reduce certain sources of bias when testing the effectiveness of new treatments. So kind of what does that mean, right? Well, a randomized controlled trial is introducing random variation in the world that is, we say in mathematics that it's orthogonal to all the other things that you might observe about the world. Really what that means is it's by design entirely uncorrelated and unrelated with all the other things that might happen in the world, even if you can't control for them. And then we use that instrument to go back and assess the effectiveness of a treatment, which might be, for example, in this case, a spend on a media channel. Now, how is this accomplished? Well, this is going to sound familiar to a lot of you. This is accomplished by randomly allocating subjects to 2 or more groups, treating them differently. So one group is, maybe you can kind of consider it the control group. They don't get anything. The treatment group gets a treatment of some sort, which might be a marketing spend. But you can also have more complex designs where everybody's getting a spend eventually, but they get them at different times. And you compare those groups based on that randomly assigned instrument that you've come up with. Now, I alluded to this earlier, I think a few of you are probably shaking your heads right now. I wish I could see because, again, we're in this weird kind of Zoom world right now, but it's a lot like an A/B test, except for paid media. And so, just to kind of go through a use case example here, you can imagine we want to evaluate the effect of paid search. Just say we're going to give some people paid search, other people we're not going to give them paid search. So what we do is we do our randomization. So we make sure that the assignment of who's going to get paid search is entirely unrelated to every other variable in the world that might influence our result to begin with, which is it's called exclusion or anti-confounding. They're kind of 2 different words for it. We treat some people with paid search based on that random instrument, and then we do not treat some people with paid search based on that random instrument. Now, what we do at the end of this thing is we compare the group who got exposed to paid search to the group that did not on the basis of an outcome variable. In this case, our outcome variable is revenue. And if we were to subtract out that $10,000 in the group that was not exposed to paid search from the group that was exposed to paid search at 25 grand, we can draw the causal inference that our paid search spend contributed 15,000 in incremental revenue. So this is a very, very basic example of how we run an A/B test, in general, right? But for paid media in particular. And one of the really secret sauces here is the fact that we're randomizing at the geographic level. Now, one piece of this that's important noting is that it introduces a certain level of complexity, right? It's a lot easier to deal with lists of individuals that we're just assigning, certain levels of spend, or maybe you do get spent on or you don't get spent on. But these certain levels of spend are assigned at the list level. Why are we assigning at the geographic level? Well, for a myriad of reasons that we're about to talk about, but in particular, number one, because it's very, very hard to track people in circumstances where they have perhaps some new privacy technology that's been deployed that prevents us from being able to track them, or there's actually no reconciliation of a unique identifier in the offline space to be able to go back and actually attribute any sort of activity to them. Moreover, we'll see in just a few minutes that display is a historically very hard thing to get a handle on, especially because you don't know when somebody saw a display ad or not in several different digital and non-digital contexts. And so for all these reasons, there might be these sort of like payoffs, right, for getting into the more complex design that goes hand in hand with geographic assignment. But you also get a lot of reward. So let me go a little bit deeper into why these testing architectures are important. And my first slide is, it's it talks a little bit about some of the out of the box analytics platform based attribution solutions, and these aren't going to be the boutique ones with private identity networks. These are going to be the very big at scale ones like Google and Adobe. And these platforms really promise very easy to use attribution for companies, that utilize any sort of marketing tech or analytics stack. And in general, the following pitfalls are what at least we've seen clients experience when they rely on the out-of-the-box solutions from these analytics platform providers. The first is decreased competitive advantage. So when your competitors are using the same attribution and optimization platforms that you are, your ability to innovate is limited, right? You want to preserve some sort of competitive advantage or secret sauce that puts you ahead of what the crowd is doing so that you can then eke out some sort of sustained advantage over time. The second thing is that there ends up being a reliance on a singular tech stack, which puts you at risk of essentially, getting the costs jacked up, right? You'll see, and this is actually, we've seen this go up significantly over time, but the cost of targeted advertising, especially on the sort of, out of the box DSPs and other, more traditional, quote unquote, in the last 20 year, right, advertising networks, it's gone way up. It's actually a lot more expensive today than it used to be, and part of that is because it's a lot less competitive of a landscape. So relying on one technology stack can definitely put you at risk. Now, finally, there's an inability to link all of the relevant data. These out-of-the-box solutions may seem pretty easy to implement, but the problem is that it really only works for a very limited set of use cases, a very limited set of variables or data. And in particular, it really only works in the digital spaces. Again, not necessarily talking about these digital versus offline, online identity graphs, but for these out-of-the-box platforms, there's sort of an economic principle at work, which is you can't go broad and deep at the same time. You can only do one or the other. But the problem for marketers is that they're trying to go deep with use case and domain specific solutions. Now, this is kind of the elephant in the room that we've been talking about for about a year, which is that increasing privacy concerns are increasing the number of users whose cookies are blocked or frequently cleared just by default. And so in this plot here, you can see you have a user, just, I don't know, you can call him Alice. And Alice clicks through to the site via display ad. But when cookies are blocked, we no longer have the link that allows us to understand that that display ad was what actually brought them through to the site and had them spend money. So even in the cases of display, which have historically been difficult to begin with, it's very, very hard to get this full click-through map when cookies are breaking down. There's another piece of this, which is that cross-device tracking is often not included. So, these days, everybody's shopping not only on their computers, but on their phones. They get OTT advertising, right, on whatever they might be watching, whether that be Hulu or YouTube TV or, something more, endemic like, Samsung's Vivo network or something that you just check out on your Vivo TV. And it's hard to get a handle on whether somebody saw a display ad on, say, for example, their phone, visited the site, didn't purchase. We see that as just somebody who fell off, right? But then they go back to their computer, right? They want a more full, little more holistic browsing experience with more detail, and they end up going through and converting. So that's another problem that we see is it's very, very hard to pull these 360-degree customer device, graph networks together to be able to do that full attribution. And we talked a little bit about this before, but especially in cases when there's no actual click on a display advertisement, it's really, really hard to understand if, when, how, and by how much that person clicked through. You can even imagine, even out of home advertising, right? It's really, really hard to attribute, because somebody's driving by in their car, they see an advertisement on the road. You have no idea if they're going to come back and, unless it's a specific landing page or a specific, brand platform that you've created to allow for that. But those are very, very few and far between. Becomes very, very difficult to do attribution based on display these days. But there's another piece of this that I want to kind of introduce, which is this idea of causal inference. And if anybody is familiar, there's a conference called I/O. It's kind of like a really, really big digital marketing conference out on the West Coast. I know we got some West Coasters in the house. I'm sure you've heard of this conference. And at this conference, people give lots of talks about what's happening in digital marketing, what's happening in advertising, and what's happening on the web, and kind of like what are the biggest trends? How can we keep up with these advances in the industry? Now, a few years ago, there was a fantastic talk by an assistant professor at Melbourne Business School. His name is Nico Newman, and if you've ever read the book The Subprime Attention Crisis by Tim Huang, he actually talks about this example too. It's a really, really, I think, poignant example of why causal inference is so important. In this talk, which was titled, by the way, How Wrong Audience Targeting and AI-Driven Campaigns Undermine Brand Growth, in this talk, he ran an experiment. Essentially, basically, he looked at some data. There was an advertising campaign for an auto insurance provider. And this advertising campaign was deployed by some of these DSPs, and they all showed a very positive ROI. It was targeted properly, it was deployed very well, had a great ROI. These advertisements for this auto insurance product were fantastic. And then what he did is he went back and he ran several experiments using that exact same advertisement on an experimental subject pool with the more robust approach to random assignment, right? So he basically randomly assigned who was shown this advertisement and who was not. And what he found was that rather than having this massively positive ROI, right, as suggested by the popular industry modeling approaches that are reported out through the DSPs, rather than having this very positive ROI, it actually looked like it was negative. The advertisement actually had a negative effect on the experimental population, and it was replicated as well. So it's really interesting that this problem of causal inference comes into play, because you can show this advertisement on any number of DSPs and they can tell you what the ROI was, but without RCTs, right, without controlled experimentation, you can never really truly know if it would have been negative or not. And I think that experiment was actually a really, really poignant explanation or exemplar of that case. Now, there's some additional bells and whistles to talk about here, and then I'll probably start wrapping up with RCTs. In some cases, you just want, basically, I want to turn on advertising in certain geographic areas and I want to turn it off, right? So it's like, I just want to evaluate, does my advertising work? Yes or no? From a benchmarking perspective, that's useful, right? Which is when I spend this much on this type of advertising in these channels, what are the ROIs I can expect? Et cetera, et cetera, et cetera. But there's other designs that are that can assist you in the analyses that help you understand exactly where your money should be spent. One of them is blocking. So statistical blocking is essentially, it's interesting to me that nobody really uses this, but it's a technique that lets you reduce, the technical term is it reduces the sampling variability of the design on the outcome measure that you care about. What does that actually mean? If it was going to take you maybe 3 months to run an A/B test, if you employ blocking, which just includes a little bit more data and just a clever matching procedure, you could probably run that experiment in 2 weeks. If you have a very small effect size that you're trying to detect, especially at the geographical level with smaller units like there's 230 DMAs that are possible, you can actually detect statistically significant small effect sizes using blocking as opposed to unblocked designs. It doesn't mean that it needs blocking, right? But blocking is very, very helpful in cases where you're doing experimentation. Now, as a sort of second piece of this, you can do factorial or multi-stage designs where maybe you're more interested in the interactive effects between channels. And so instead of going back and saying, let's interact these two channel variables in our media mix model, which is for we won't go into detail, but in a linear regression, you can get interactions out of a model. Instead, let's by design introduce interactions between those spend levels and see if there's any sort of combinatoric effects of several different marketing channels. And finally, and this is actually one that we've seen a lot of like interest and success with, is the stepped wedge element of the design. And essentially what stepped wedge design lets you do is if you're going to spend 10 million and you want to make sure that you are definitely spending that 10 million because you don't want your budget to get cut, or you want to make sure that you're actually advertising to everybody that you could advertise to, you can run an experiment with a stepped wedge design that lets you still get a control group and treatment group that's randomly assigned, but treats every single unit at varying time periods over time. So, or varying periods over time, I should say. And what the stepped wedge lets you get at is, sort of, I still spent 10 million. I still treated everybody with marketing that I wanted to treat with marketing, but I now have additional information, right? Such as what are those benchmarked effects? What are those interactive effects? And in addition, what does my spend response curve look like, right? Am I spending enough in the areas that I need to be spending? Am I spending too much? What would be the optimal level of spend by channel? Just a quick example. This is this is a geo-randomization from a recent RCT that we ran. And you can see that this is a stepped wedge design, and kind of the plot is the United States of America, but you can see the borders are a little funky. So these borders are actually DMA areas as opposed to kind of states or zips or precincts. And these DMAs around the US can, you can treat them as places where you give marketing activity on TV, on social. You can target your campaigns of programmatic to these different areas. And if you look on the plot, the shaded areas are DMAs, which in this first month of this RCT were treated with this marketing activity. Now in the design, you randomly select and vary spend levels across all these DMAs so that you get basically in month 1, certain DMAs are treated. In month 2, again, this is all randomly assigned, right? So it's not by any sort of hand picking. It's generated by a computer with a random instrument. You treat more people, but in different DMAs. So you have a separate treatment group, and then in the final one, you treat the remaining DMAs. And that sort of progression is essentially, if you imagine each one of these almost as like radio signals, that's exactly what you're doing. Is you're going from month 1 to month 2 to month 3, and then you're going out and backing out the actual estimated effect of those marketing channels in those DMAs. And I would be remiss if I didn't talk about these RCT approaches as part of an ongoing optimization process. I'm sure that we could do another talk on this at some point. I think hypothesis-driven testing, hypothesis-driven analysis is an incredibly important tenet for people to hold in their organizations. But I think it's just important to call out that this isn't just one experiment that you would run. You can run RCTs in an ongoing fashion to be able to generate ongoing insights and continue to optimize across all the marketing strategies. Now, in this final section, I just want to talk a little bit more about, I get a lot of this, right? Which is kind of the machine learning thing. And, I'm a data scientist, right? I'm a PhD trained literally in how to do all these machine learning things. And the amount of times that I get sort of like, well, why can't we just use the machine learning capabilities that are in the platform, right? I mean, the platform has machine learning. It's got, I don't know if you're familiar with machine learning, but it's got machine learning. So we should probably let it go. And the truth of the matter, and if you take anything away from this talk, other than the fact that RCTs are fantastic, the other thing that I would want you to take away is that machine learning cannot introduce random variation into the world, okay? Machine learning cannot introduce variation that lets you make causal inferences into the world. Only humans can do that. What machine learning can do is help you estimate based on that design, ex post, right? But machine learning is never going to be able to actually get you a causal effect estimate. It takes some sort of design-based thinking and some random variation in the world to really draw those inferences and conclusions. And I'll close just by talking about, this promise of the 360-degree customer view and how it relates back to machine learning. And for everybody on the call, again, cookieless is such an important topic. The 360-degree customer view was, we could see everything. We could see where you ate. We could see where you shop. We could see where where your home was. And by seeing everything and knowing all these things, we could then basically do anything, right? We could understand you at a very individualized, and I'm probably going to have to wrap up in a second, individual level. We could advertise to you in a way that makes you more likely to convert, and we could basically, we would know everything, right? Anything we wanted to do, it was possible. Now, the problem is that is very broken, especially as we go into a cookieless world. Not only is it really ultimately an untenable solution, right? It's very significant investment just to be able to gather these data to begin with, but it's not necessarily going to provide us with value to customers in a meaningful causal way. And the implications of this as we go forward are that, we're going to lose transparency. We're going to have a major lack of transparency in the way that we do analyses. And we're going to end up seeing a trend of impersonalization over time. And this lack of transparency is kind of this idea. It's like, these big data that we've been assembling, honestly, they're almost too big, right? And too complex, too costly to centralize, too costly to maintain. Even basic comprehension of them takes a significant investment. And it's a little bit funny to think back to these RCT designs where it's a few hours of thoughtful implementation of your marketing spend to get you to insights. You don't actually have to collect all that data. You could actually come up with those insights just by clever design. When it comes to impersonalization, as we get this further degradation of these individualized attribution technologies, it's going to be a lot harder for us to kind of like actually do things that are meaningful for customers based on broken data. And, I'm going to encourage people a little bit more to think about building models that make inferences at sort of like, micro segmented levels that you then go back and deploy to individual level customers. And why do you do that? Well, why do customers do things? It's because they see other people doing the things that they want, right? They see other things, they say, I want that. And the only way you get that in the mix is not by looking just at the customer. The customer doesn't know what they want just on their own. They have to get that information from somewhere else. So you have to look at groups of customers to be able to really fully understand that. All right, now the final piece of this, I'll just end with this, is machine learning is truly, it's not the solution to attribution. This is, I don't know if you've ever seen this, but this is from a very common Google Vision API. If you throw this image of a Chihuahua in there, you will it'll think it's a Chihuahua. If you throw this picture of a muffin in there, it'll also think that it's a Chihuahua. And you can very clearly see why this is the case just based on the layout of these images. But as you think about machine learning, just remember that all it's doing is looking at data and trying to generate, some sort of thing that it's seen in the past about. You can't actually get any novelty out of machine learning. And oftentimes that's why it goes so wrong. All right, so I'll conclude with that. I really appreciate everybody's time. And I guess I'll hand it back to Brian.
All right. Thank you, Dr. Joe. That was great. So we do have time for some Q&A before we hit the breakout. So if anyone wants to share any questions in the chat, Tim, I don't know if you've been monitoring that at all.
Been monitoring it. There's a lot of plugs for the Freakonomics, for the subprime attention crisis book that Joe referenced, that then went to the Freakonomics. Freakonomics Radio did a 2-part podcast series on advertising. That then went to me shamelessly plugging the Analytics Hour. We had an episode with Joe on this topic, but we also had an episode with Tim Huang on subprime attention crisis. But I was not seeing other questions, but I'm happy to float one to see what kind of a curveball I can throw Joe. Oh, we have a question. So I won't get to, now I'm going to throw mine in first anyway. So what about something like, because the guy I used to work with, who's an organic search guy, who was on long enough to say, is this going to be recorded? And then bailed. But I know the question he would ask is, he's an SEO guy. So when it comes to something, you've talked about paid media, can you factor in sort of does organic search, which is much more challenging to kind of control geographically? Do you have any thoughts on how you can factor in the impact of that? And that was rude. That was me being rude.
Yeah, Tim, you're such a rude guy. I'm sorry. Can you restate the question?
So with you talked about kind of blocking and stepped wedge and things where you can control, where you can do your test and control based on geography. But what happens if you're using like your organic search investment and you're trying to say, I'm going to make this change to you have the ability to control your content and your technical SEO, but you don't have the ability to control geographically who it's exposed to. Does that kind of just needs to fall under some different kind of a longitudinal type thing?
Well, I think if you're doing that type of optimization, you're falling back within the site context, right? So all of a sudden you open yourself back up to the A/B testing world, right? Which is, if I want to know if this content is performing well for me at a sort of micro optimization level, then let's run an A/B test on the deployment or the availability of that content. We've also done some other, for example, and I can't reveal the name of the client, but we've done for a certain retailer, geo-specific, right? So geo-specific organic search optimization for certain retail stores that are in certain geo areas. So you get a geo level randomization for the opportunity to go directly to those landing pages and that content, but you exclude the others. It only works because their site is structured in a way that lets you do that, right? But I guess it's two answers, right? One is, yes, you can still do geo randomization if the site is structured that way, and it could be useful. On the flip side, if you're just thinking about certain types of content itself and not necessarily content structures, why not just go back to regular A/B testing?
I like it. Thanks.
Cool. Well, Aaron asks, what is a real world reason for marketing spend having a negative lift? The promos made someone ask for a refund?
I mean, it's a really great question, but I'm sure that we can all think back to times and advertisements that we've seen, maybe just even from a creative perspective, that made us be like, I'm not sure how I feel about that. One of the things that's being discussed a lot right now is the sort of spread between, I don't know if anybody watched the Super Bowl, but there was a very palpable ideological spread between the Fiverr ad that was shown kind of around it was around the Four Seasons. It was like a huge joke about the Four Seasons debacle that happened with the Trump press conference. And then there was another one which people were comparing to it, right, which was the Bruce Springsteen sort of Unity in the Middle America commercial. And there's a very clear reason why those advertisements might have negative conversion effects amongst certain people of different ideological bents, right? I mean, there's a very clear story behind why somebody who's very conservative might really balk at this, making fun of the Four Seasons advertisement, or somebody who's very liberal might balk at this, more sort of Jeep-oriented Bruce Springsteen ad. So just another, I think, opportunity to discuss. But I'm sure we can all think of examples.
If your advertising was actually not actually, if it was having a lift, but it was so small that you weren't getting an ROI, you could have a negative lift if you're saying we're doing advertising, but people would have bought anyway. I mean, that one kind of recently sort of blew my mind, that when traditional multi-touch attribution says we made $1,000, we are going to assign $1,000 across the channels that we were actually tracking to, and it completely ignores the fact that somebody may have bought anyway. So would that not be potentially, if you had really ineffective advertising because you spent money?
Yeah, I mean, Tim is referencing an exercise that we recently went through internally, where we showed essentially that you can have a very ridiculously positive ROI if you take credit for people who were going to buy your product anyway. But when you go back and look at the marketing investment and you ask the question, well, did our marketing actually change anybody's minds? Or, did it take somebody who didn't know about the product to make them go ahead and buy it? When you introduce that variable into the estimation, you get a very negative ROI on your marketing investment, because turned out that you were spending it in all the wrong places, right? So I think that there's two pieces of that, Tim. I mean, one is just the methodologies for estimating ROI. I think there's some flaws there, but there's also this causal orientation problem that we have to be able to deal with. So I love this topic. It just goes deeper and deeper. I mean, it's so interesting.
So our next question is from Katie, and I'm going to let her read this one. So the group gets to meet you because you are the fabulous new volunteer for Columbus Web Analytics Wednesday.
All right, sweet. Putting me on the spot here. So, so this question, I think is more so, I work at a small agency, and we don't really have like client budgets or patience to test in some of the ways that you were talking about, which I think is great. But I'm trying to think of different ways that we can start thinking about changing our tracking now to prepare for this cookieless world. I've been reading up about like server-side tracking and client-side tracking, and what I can do on my end. We don't have like an analytics team or anything either. It's sort of me at the moment, so I'm just trying to think of different things that we can do. We've got about 60 websites that we manage, so something that I can scale, but also just start working on and just thinking about different ways that with our display ads that you talked about. You made a good point there, and just so many different things are going to be changing, and how can we better attribute knowing that this is coming?
So I'll kind of just take, it's an interesting question. It's more about kind of cookies in general and what to do, right? And I'll kind of give you a quick taxonomy and then direct you towards the real expert resource on this, which is Corey Underwood at Search Discovery. But high level, right? There's technical changes that you can make today, right? That make your site a little bit more robust, a little bit more compliant with this new privacy-driven world. Those are things like changing to server-side tag management, things like, investing in CNAME, and like those types of things that are going to help you get better just technical viability in the short term, because these platforms are making changes. But there's longer term investments that, you might think about making that are more based around this idea that you want to measure the right things at the right, what are called units of analysis. So from an analytics perspective, even though people might be asking you a question about individuals, you might really have an answer for, people who live in certain types of neighborhoods. So it's a different question at a different level of analysis or unit of analysis or level of aggregation. And thinking strategically about the measurement frameworks that you put in place to be able to report on those units, I think is probably one of the most prescient things you could invest in at the moment. And instead of thinking about individual level tagging, individual level reporting, how can we put a measurement framework in place that really gets us to the answer that we want? Now, I told you I was going to do this, but definitely go look up on Search Discovery's blog. There's several posts by Corey Underwood, and we have a few other people who have been involved, but they've been cutting this thing to shreds. I mean, they're keeping the pace of changes is so rapid. It's interesting to me to see how rapid this industry changes, but it's also very impressive to see how quickly they respond to it. So that would be my final encouragement to you. I think thank you for the question. A very good question.
Thank you, Dr. Joe.
All right. So we have a question from Nick here, and Joe, he says on the example of block testing running SEM and a geography A and no SEM and geography B, and then comparing the revenue from each, what about the natural difference in purchase behavior between the two geos? Like Geo A may purchase something more regardless, for Geo B and the advertising that they're seeing. So do you need to introduce certain baselines for your blocks first?
All righty. So great question, Nick. And Tim is smiling because I love when people ask this question. I
don't know if you can answer it without a whiteboard is what's going to be really interesting.
I'm also notorious for whiteboarding. It's because I used to teach, as everybody has, I guess, knows from my introduction. So old habits die hard. So look, when you're, so let's start just with this idea of test and control. I think traditionally people have been like, I'm going to pick this geo and I'm going to compare this geo to this other geo. And I need to control for the fact that there might be differing baselines. I mean, New York is going to be spending a lot more, right, than like, Montgomery, Alabama, because New York City is just a bigger city. So it wouldn't make sense to directly compare a New York, revenue number to like a Birmingham, or a Montgomery revenue number. But when I say geos, we're thinking about groups of geos, number one. So this is not just any individual geo being compared to another. This is a list of geos being compared to, and this is important, a very balanced second list of geos that have the treatment, or a third list of, et cetera, et cetera, et cetera. Blocking is the technology that lets you make sure that there's incredibly precise balance between those groups. Now, the second piece here is just the element of randomization. So randomization in itself is a technique that prevents us from reading too far into those pre-existing differences. And randomization essentially creates what we call this instrument, right? And it's orthogonal or unrelated to the price that we might, the revenue that we might be seeing coming from different DMAs. And so on average, even though individual DMAs are all idiosyncratic, they're all a little bit weird. When you group them together and you randomly assign who's in what group, and on top of that, you match to make sure there's balance, randomization, the magic of randomization kicks in, and you have to worry a lot less about the baselining. Small caveat to that is usually I encourage people to use what's called, covariate adjustment in their estimation. That just means that instead of looking at the absolute difference in revenue numbers, you look at the difference in differences, which is you subtract out the, you have a revenue number you looked at today, you subtract out the revenue number you looked at yesterday, you get the little marginal difference, and you compare those marginal differences across, groups A and B, or geos A and B. That'll help you a lot too. And all those things in concert, which are all the things that we use, really take care of the problem. A very good question. Thank you.
So I'm going to kind of pull together some of the questions, but make it in a way that, Joe, I think you can kind of build on this. So keeping the last question in mind, Matt asks, what techniques do you recommend for isolating variables when advertisers don't want to stop spending in multiple channels?
So generally, you can still run an RCT while still spending in all the channels, right? And you can just do little teeny variations in the levels of spend with the stepped wedge design. So you're still spending the same amount over the whole course of the campaign. Really so the techniques, namely, right, are block randomization plus stepped wedge design. And that's really it, right? If you're trying to explain it to an advertiser, I think the easiest way of explaining is just saying, like, we're going to spend the same amount of money. We're going to do it in the exact same channel strategy that you've, wanted to do. We're just going to do it in a little bit of a different way that gives us insights based on those channels. And you don't have to necessarily turn off the spend by any sort of means. You just get more insights based on this clever design.
And then putting Ty's question kind of on that as well. So basically, he's kind of taking the gist of what Matt was saying and saying, how does it look when you scale to multi-touch with multiple ads over time leading up to the conversion? Does it start to look like a really complex ongoing test at that point?
Okay, so now we're getting into the cutting edge. So there are, at a basic level, sorry, I should rephrase that. There is, at a basic level, no real restriction in the number of, interactions you can develop in a multi-factor, design, right? You can even do a full factorial design if you want, and get every possible outcome that you would like to see. The problem is that you end up getting increasingly small groups and small spends. And so the real limiting factor is that you can't necessarily get, all the things that you want in one shot. Because you can't spend that little in an area, see something show up, or you can't look at like that few people in an area and actually get what you want to see. So one of the sort of like better answers right now is you can get up to about 3 interaction combos at the moment, and still have, statistical significance. Make sure you actually do some sort of multi-factor design, but do it in a way that, maybe gives you up to 3 interactions. Now, the sort of, and then use those hypotheses that you generate based on the conclusions that you've gotten from that experiment to then do another, test of sort of like, maybe an interaction between 3. Now, I'll kind of plug this, but this is a very, very, more, I guess I say, very like cutting edge technique, which is essentially applying these treatment designs in the field in an ongoing fashion over, you can do this over like a 1 or 2 year period. And essentially, it's, I don't know if you're familiar with what are called multi-arm bandits, but you can actually run these experiments as multi-arm bandits at scale in the field. And so that's eventually going to, I think, be where people go if we can get programmatic up and running at the granularity that's necessary.
Awesome. So I think with that, we're going to wrap.